Dr. Synapse.
The ECG. In the right, we have a normal ECG. In the second lead, the ECG gives us information about the voltage and the duration of the electrical signal of the heart. In the x-axis, the ECG will record a time. A small square is equal to 0.04 seconds. In the y-axis, the ECG will record a voltage. A small square is equal to 0.1 millivolts. The electrical signal begins in the sinus node. This sinus node is a mix of a bunch of cells in the upper side of the right atrium. It is responsible of normal heart rhythm, also called sinus rhythm. The conduction of the sinus node will travel through the Bachmann bundle to the left atrium. Therefore, the first wave recorded in the ECG is the P wave. We can split the P wave into two parts. First electrical signal is the right atrium. The second one is the electrical signal of the left atrium. The electrical signal will then reach the atrioventricular node, also called AV node. The AV node is a bunch of small cells and calcium-dependent cells. Thanks to this composition, the AV node will slow down the conduction. The conduction of the small cell is slower than the bigger one, and the conduction of the calcium-dependent cell is slower than the sodium-dependent cell. This mechanism is very important because it allows the contraction of the atrium to fill the ventricle. This slowdown of the AV node is also recorded in the EKG. It is the PR interval. It should not be more than one big square. The electrical signal will then head to the ventricle by the His bundle. The His bundle will split into a left bundle and a right one. It will then end by the Purkinje fibers. The ECG will record QRS complex. The QRS complex is the ventricle depolarization. This depolarization is fast because it uses sodium channel. First, the Q wave, because of the depolarization of the interventricular septum. Then we will record a high R complex because of the depolarization of the other cells of the cardiac muscle. Also, at the same time, we have the repolarization of the atrium. But the repolarization of the atrium will be hidden by the depolarization of the ventricle. Why? Because we have more ventricular cells than atrial cells. That's why the QRS complex hidden the repolarization of the atrium. After this, the ECG will record a period without electrical signal called ST segment. During this period, the ventricle contracts to pump blood to the aorta and the pulmonary artery. Finally, the ventricle will become repolarized. The ECG will then record a T wave. The repolarization is a slow process. That's why this T wave is wide. Thank you for watching this video. Feel free to write me a question, a comment, or a subject of interest.